Hello everyone, I am Dr.S.ARUNKUMAR, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology, Coimbatore. So in this lecture series, I am going to discuss the subject thermal engineering topics, particularly air compressors. In this video, I am going to discuss about the types of air compressors and their applications. So this is the agenda of this presentation. I am going to discuss about in this way classifications of rotary compressors. There are two types of rotary compressor. One is a positive displacement type of rotary compressor and another one is dynamic actions, and specific types and characteristics of rotary compressors like van compressors, screw compressors and lobe compressors. The lobe compressor is nothing but it is called as roots blower, and then we going to discuss about the thermodynamic process, isothermal, adiabatic and the polytropic process, and design thinking concept, finally the future trends. In the rotary compressors, there are mainly classified into two types. One is positive displacement type, another one is dynamic action or steady flow type. The positive displacement type again classified into four way, that means root blower and lysolem, and the screw type rotary compressors, van type compressors. In the dynamic action further classified into two types, centrifugal type and also the axial flow types. So first, introduction to positive displacement compressors. The positive displacement compressors that captures the fixed amount of a gas and force it into the smaller volume. That means it increasing its pressure. This fundamental principle is underpins the various rotary designs. And also in this slide, we are going to discuss about the some of the thermal processes like isothermal process, adiabatic and polytropic, and PV, that is pressure and volume core. In the isothermal process, the constant temperature curve, that means P into V is equal to constants. In the adiabatic and polytropic process, it's steeper adiabatic and intermediate polytropic. In the PV core, the pressure versus volume axis labeled clearly. So van compressors, principles of van compressors and the operations. The van compressor uses the rotor, that means rotating element, with sliding vans to trap and compress the air within the cylindrical housing. And they are known for their simplicity as well as the smoother operations. The sliding vans, it extend and retract to trap the air. So in this slide, we're going to discuss about the process flow. The first rotor, it drives the van motion as well as the rotations. The second one is the sliding vents that extend and retract to the trap air. And third process is eccentric casing. It creates the variable chamber volume. And finally, inlet to outlet, air drawn in and compressed and expelled. So screw compressor, the single and tuned screw designs. The screw compressor utilizes the two meshing helical rotors, that is so that it is called tuned screw, or a main rotor and gate rotors. The gate rotors, it is called single screw to compress the gas continuously. They offer high efficiency as well as the reliability. So these are the process how the air is compressed inside the screw compressors: compression chamber, inlet port, discharge port, and intermeshing rotors. The first one is the inlet port. In the inlet port, air enters through a controlled inlet. And second stage is intermeshing rotors. The helical tuned rotor, it traps and move the air inside the compressors. And third stage is compression chamber. The gas volume reduces between the rotor lobes. Finally, the discharge port, compressed air exists under the high pressure. So the lobe compressors, also called as the roots blower. The function and characteristics of lobe compressors are: the roots blowers or lobe compressors use the two counter rotating lobed rotors to move the fluid through the system. While not truly compressed internally, they provide the significant pressure increases through the external compressor. These are the working flow: inlet capture, counter rotation, non-compressive. Third one is the positive displacement, non-compressive transfer, and finally outlet delivery. In the inlet capture, figure 8 rotors trap the incoming air, and the counter rotations, rotor spin opposite to the transfer pockets. In positive displacement phase, air is carried between the lobes to outlet. And non-compressive transfer stage, there is no internal compression during the transit. Finally, the outlet delivery, air exists elevated pressure to the working system. So these are the real world applications. First one is the industrial air systems. So the rotary compressors are indispensable in numerous industrial settings, that providing the compressed air for their tools, processes, and automation. So in the industrial air systems, the reliability of rotary compressors is critical for continuous operations. So let us discuss on case study. A large automotive manufacturing plant relies on a centralized screw compressor system to power the robotic assembly lines and the paint shops, ensuring the consistent pressure and the minimal downtime. So coming to the design thinking concept, the first stage is empathize stage to understand the user's need to design the truly effective compressor solutions, and engineers must first deeply understand the challenges and requirements of the end users, that means customers, and the operational environment. This involves observing the current systems, listening to the operator feedback, and identifying the pain points such as energy consumption and also noise level produced by the rotary compressors and the maintenance demands. And design thinking ideate stage, innovative compressor solutions. The ideation phase foster the creative problem solving, generating the wide range of potential solutions to address the identified user need, such as power consumption, coming to the user's need, as well as the maintenance issues, from minor environment to the radial innovations. So brainstorming sessions might explore the new rotor profiles for efficiency increasing and advanced materials used for durability, or smart control system for productive maintenance as well as the energy optimizations. So some of the key comparison of rotary compressor type, there are three types of rotary compressors: the van type, screw type, and the lobe type. The van type is a simple design, compact design, and the smooth operations, and also it gives the lower pressure ratios wear on the vans and small workshops, dental clinics. These are applications of van compressors. Screw compressors, it is high efficiency and continuous flow compressors, and also reliable. Coming to the cost wise, it is higher than the van type compressors and complex manufacturing. Applications are industrial manufacturing, large scale systems. Low or roots rotary compressors, high volume flow and robust and good for the static gases, no internal compressions, no production of noise. Applications are pneumatic conveying and the supercharged. These are the some key comparison of different types of rotary compression. Finally, the summary and future trends in rotary compressor technologies are the rotary compressors play a vital role for industry and continuously evolving with the advancements in materials, smart technology, as well as the energy efficiency. The future trends focus on the sustainability and also the connectivity. Key trends includes the IoT, such as Internet of Things, integration of predictive maintenance, as well as advanced variable speed drives for energy savings, and the development of oil-free compressor for the sensitive applications. Thank you for your watching. These are the references I have gone through for this presentation. Thank you.